The Pantheon in Rome has stood for nearly 2,000 years. Its unreinforced concrete dome, the largest of its kind ever built, has survived earthquakes, floods, sackings, and centuries of neglect. It has never been patched, it has never been reinforced, and it has never leaked. Meanwhile, somewhere in America right now, a house built 5 years ago has a jagged crack running down its basement wall, and water is seeping through it every time it rains. How is that possible? How can ancient Roman engineering outlast our modern construction by a factor of 400? The answer involves a material so simple and so inexpensive that it has been sitting on hardware store shelves for decades, hiding in plain sight. A 10-pound bag costs about $16. It uses the exact same chemical principle that let Roman harbors strengthen underwater for 2 millennia. And for most common foundation cracks, it creates a permanent, watertight seal. Yet the average American homeowner pays over $5,000 when a foundation crack appears. Some pay $8,000, $10,000, even $15,000, depending on the severity. Not because the material is expensive, not because the labor is exotic, but because most people have simply never heard of this product, and they do not know how to tell the difference between a crack that needs a $16 fix and one that genuinely needs a structural engineer. That is what this video is about. We are going to give you both pieces of that puzzle, the material and the diagnostic skill. By the end, you will know exactly when to fix it yourself, exactly how to do it, and exactly when to call a professional instead. Welcome back to Historia Prime. The chemistry. The Romans stumbled into. Sometime around the 2nd century BC, Roman builders working along the coast near the Bay of Naples made a discovery that would reshape civilization. They noticed that when they mixed volcanic ash from the slopes of Mount Vesuvius with burned limestone and seawater, the resulting morite did something no other building material could do. It hardened underwater. Not slowly, not weakly, it hardened into stone, and then, over the following decades and centuries, it actually grew stronger. We now know why. In 2017, researchers at the University of Utah published findings showing that as seawater seeped through Roman marine concrete, it triggered a chemical reaction that produced rare interlocking crystals called aluminous tobermorite. These crystals literally grew inside the concrete, filling microcracks and reinforcing the structure from within. The ocean was not destroying Roman concrete, it was feeding it. Then in 2023, an MIT research team led by Professor Admir Masick uncovered another layer to this story. Those white lumps scattered throughout ancient Roman concrete, the ones historians had always dismissed as sloppy mixing, turned out to be reservoirs of reactive calcium. When cracks formed and water seeped in, these lime clasts dissolved and recrystallized, sealing the damage automatically. The Romans had accidentally invented self-healing concrete nearly 2,000 years before anyone understood why it worked. When the Roman Empire collapsed, much of this practical engineering knowledge fragmented and faded. It was not that hydraulic lime vanished entirely from European construction. Builders in some regions continued using variations of it throughout the Middle Ages. But the systematic understanding, the deliberate science of matching volcanic pozzolans to specific marine and structural applications, that was largely lost. Centuries of castles leaked. Centuries of harbors crumbled. It took until the 1750s for someone to rediscover the principle in a rigorous scientific way. In 1756, a British engineer named John Smeaton was tasked with rebuilding the Eddystone Lighthouse off the coast of Plymouth, a structure that had to survive constant battering from North Atlantic waves. 2 previous wooden lighthouses on that same rock had already been destroyed. Smeaton experimented methodically with different combinations of limestone and clay, tested them in salt water and fresh water, and identified the exact chemical properties that produce what he called hydraulic lime, a binder that sets and cures underwater. His lighthouse, completed in 1759, stood for over 120 years. It was only decommissioned because the rock beneath it eroded, not because the concrete failed. Smeaton's work laid the foundation, quite literally, for the development of Portland cement in the early 1800s, and eventually for every modern hydraulic cement product you can buy today. The same fundamental chemistry, calcium silicates reacting with water in a process called hydration, connects a Roman harbour wall to the bag of powder sitting on a shelf at your local Home Depot right now. Why most people have never heard of it. So if this product is so effective and so cheap, why does almost nobody know about it? This is not a conspiracy. Nobody buried this knowledge or locked it behind closed doors. The answer is much more mundane and, honestly, more interesting. Hydraulic cement is a generic, unpatentable product. Any manufacturer can make it. That means no single company has enough profit margin to justify a national advertising campaign for it. Compare that to a proprietary foundation repair system with branded peers, patented injection methods, and certified installers. Those companies can charge premium prices, which funds their marketing, which creates consumer awareness, which drives more business. It is a self-reinforcing cycle. The expensive solution gets all the visibility. The cheap solution sits quietly on a bottom shelf next to bags of grout. There is also a legitimate reason contractors charge what they charge. A professional foundation repair company carries insurance, provides a transferable warranty, operates a fleet of trucks and specialized equipment, pays trained technicians, and most critically, takes on the liability of diagnosing whether a crack is cosmetic or structural. That diagnosis is genuinely valuable, and getting it wrong has serious consequences. A contractor who seals a structural crack and something fails later can face lawsuits, so their pricing reflects not just materials and labor, but risk. What we are doing in this video is different. We are not replacing the contractor. We are giving you the diagnostic knowledge to make an informed decision about whether you need one. For the roughly 70 to 80% of foundation cracks that are non-structural, you can handle it yourself for about $16 in materials. For the remaining 20 to 30%, you will know exactly why you are hiring a professional and what they should be doing. Diagnostic survival. Reading the scars on your foundation. Before you touch a bag of hydraulic cement, you must learn to read your foundation the way a doctor reads an X-ray. Applying cement to the wrong type of crack is not just a waste of money. In the worst case, it can mask a progressive structural failure, hiding the symptoms while the underlying problem worsens. This diagnostic skill is the most valuable thing you will take from this video. Foundation cracks fall into two broad categories: non-structural and structural. Let us walk through each one. Non-structural cracks, the ones you can fix. Most foundation cracks fall into this category. They are the natural result of concrete doing what concrete does, shrinking slightly as it cures during its first 28 days, expanding and contracting with temperature changes, and settling gradually as the house adjusts to the soil beneath it. Here is how to identify them. First, look at the width. Hairline cracks, typically less than 1/8 of an inch, are almost always non-structural. Second, look at the direction. Vertical cracks and slight diagonal cracks that run more or less up and down the wall are usually benign. The vertical load of your house passes on either side of these cracks to reach the footing below, so the crack is not interrupting the structural load path. Third, monitor them over time. Non-structural cracks are relatively stable. They do not dramatically widen from season to season. You can test this by drawing a pencil line across the crack and checking it after a few months. For these types of cracks, hydraulic cement is your permanent weapon. Structural cracks, the ones that need a professional. Now the cracks that should make you pick up the phone instead of a trowel. Horizontal cracks running sideways across your basement wall are almost always a serious warning. They indicate that hydrostatic pressure from saturated soil outside is physically pushing your wall inward. Stair-step cracks in concrete block or brick walls signal differential settlement, meaning one part of your house is sinking faster than another. Any crack wider than 1/8 of an inch, or one that is noticeably wider at the top than at the bottom, is telling you the foundation is actively moving. Look for secondary signs upstairs too. Floors that have developed a noticeable slope. Doors that used to close properly but now stick or refuse to latch. Gaps appearing between walls and ceilings. These symptoms, in combination with wall cracks, point to a foundation that is failing under load. Here is the critical technical reason why hydraulic cement cannot fix structural problems. Hydraulic cement cures to a compressive strength in the range of 3,000 to 5,000 pounds per square inch, depending on the product. That means it is extremely hard and completely rigid. If your foundation is actively shifting, this rigid patch will simply crack again. Structural problems require solutions that can accommodate movement. Carbon fiber reinforcement straps, steel push piers driven into stable bedrock, or helical piers. These are engineering solutions, not DIY solutions, and they require a structural engineer's assessment. Do not skip this diagnostic step. 5 minutes of careful observation can save you from a catastrophic mistake. The holistic defense, managing water before it reaches your wall. Before we get to the hands-on repair, there is a critical strategic step that most DIY guides skip entirely: dealing with the water itself. Sealing a crack without addressing the water pressure behind it is like mopping a floor while the faucet is still running. You win the battle, but lose the war. Here is why water pressure builds against your foundation in the first place. When your house was built, construction crews dug a hole larger than the foundation, poured the concrete, then pushed loose soil back against the exterior walls to fill the gap. This backfilled soil is much looser and more porous than the undisturbed earth surrounding it. Engineers call this the clay bowl effect. When it rains, water rushes preferentially into this loose ring of soil, creating a zone of saturated earth pressed directly against your basement walls. The resulting hydrostatic pressure can amount to thousands of pounds of force, physically shoving water through the microscopic pores and cracks of your concrete. A hydraulic cement plug can resist this localized pressure brilliantly, but it does not remove the water. If you do not relieve the pressure, the water will simply find the next weakest point. Start by looking up. Your roof collects hundreds of gallons of water during a single storm. If your gutters are clogged, or if your downspouts dump water just a foot or two from your foundation, you are actively feeding the clay bowl. Clean your gutters regularly and extend your downspouts to discharge water at least 6 to 10 feet away from the house. Next, look at the ground around your walls. The soil should slope away from your house, dropping a minimum of 6 inches over the first 10 feet. This gradient acts as a natural diversion system, using gravity to carry rainwater away before it can soak down to your foundation. And one more thing, if you walk into your basement and notice a white, powdery, salt-like substance coating your concrete walls, do not ignore it. That is called efflorescence. It is direct physical evidence that water is migrating through the concrete, dissolving minerals along the way, and depositing salt crystals as it evaporates on the inside surface. Do not paint over it. Standard paint bonds to the salt, not the wall, and it will peel off in sheets. Scrub the efflorescence away with a stiff wire brush and a diluted acidic cleaning solution. Let the wall dry completely, and then apply a quality masonry waterproofer designed to penetrate and seal the concrete pores from the inside. Handle the water management first, then seal the crack. This sequence matters. The ancient art of sealing active leaks. Your diagnosis points to a non-structural crack. You have managed the water sources. Now it is time to apply the lessons of 2,000 years of engineering. Here is your step-by-step guide. Step 1. Protect yourself. Hydraulic cement is an industrial chemical compound. The dry powder contains crystalline silica, which is classified as a carcinogen with long-term repeated exposure. A single DIY project does not create the kind of chronic occupational risk that industrial workers face, but even one exposure warrants proper protection. The hydration reaction also produces a highly alkaline environment, with pH levels that can exceed 12, which will cause chemical burns on bare skin or eyes. Wear a dust mask rated for fine particulates, sealed safety goggles, and heavy-duty alkali-resistant gloves. Work in a ventilated space. This is not optional equipment. This is the price of doing it safely. Step 2. Prepare the crack. You cannot simply smear cement over a surface crack. You need to give the expanding material a geometric shape to lock into. Take a cold chisel and hammer and carefully widen the crack so that it is slightly wider at the base, inside the wall, than at the surface. This profile is called a dovetail undercut, sometimes described as an inverted V-shape. Think of it as a keyhole. When the cement expands during hydration, it pushes outward against these angled walls, mechanically wedging itself permanently into the concrete. Without this undercut, the expanding force could push the plug right back out. Once chiseled, scrub the crack with a wire brush to remove all loose debris, dust, and old paint. Then wet the crack thoroughly with clean water. This sounds counterintuitive, but wet concrete bonds far more strongly with new hydraulic cement than dry concrete. The moisture prevents the surrounding wall from sucking water out of your fresh mixture before it can cure properly. Step 3. Mix against the clock. Hydraulic cement sets in 3 to 5 minutes. Once you add water, you are racing a chemical clock. Do not mix the entire bag. Mix only what you can apply within 2 to 3 minutes. In a clean container, combine powder and water according to the ratio printed on your specific product's packaging. Different brands vary, so always follow the manufacturer's instructions rather than a generic recipe. Stir rapidly. You are aiming for a thick, stiff consistency, like peanut butter or heavy putty. Every extra drop of water weakens the final strength of the patch. Cold water will buy you slightly more working time. Warm water accelerates the reaction. Step 4. Apply and hold. For an active leak, where water is visibly flowing through the crack, you will use what is called the plug method. Take your thick mixture and knead it into a stiff ball in your gloved hands. Hold it for about a minute. You will feel the ball growing warm through your gloves. That heat is the exothermic hydration reaction, the exact same chemistry that hardened Roman harbour walls under the Mediterranean Sea. The moment it feels warm, press that ball firmly and directly into the leak. Do not twist it, do not smear it. Press with heavy, steady, unrelenting pressure for 3 to 5 full minutes. If your hands get tired, use a flat piece of wood to maintain the force. The water pressure will fight you, but the expanding cement will fight harder. As it hydrates, it expands into every microscopic void, mechanically wedging itself against the walls of the undercut and cutting off the water flow completely. For a dry or merely damp crack, you can use a trowel to firmly pack the cement into the prepared fissure, smoothing it to match the wall contour. Keep the surface damp for about 15 minutes to ensure a complete, even cure. Important: clean up immediately. Hydraulic cement becomes extremely difficult to remove once it sets. Wipe down your tools, your gloves, and any surfaces that got splashed within minutes of finishing. Do not wait until the job is done to start cleaning. Other applications. This same material works for more than just wall cracks. If you have concrete block walls with crumbling mortar joints, you can grind out the failed mortar and repoint with hydraulic cement. Have a gap around a plumbing pipe where water or insects are getting in. Chisel a small pocket around the pipe and pack it with hydraulic cement to create a rigid, watertight seal. Just remember that the cement seals the gap. It does not protect the pipe itself from corrosion. That is a separate issue. Conclusion. 2,000 years ago, Roman engineers mixed volcanic ash with burned lime and seawater and built harbour walls that are still standing on the Mediterranean seafloor today. They did not understand the molecular chemistry. They did not know about tobermorite crystals or calcium silicate hydration. They just paid close attention to what worked, refined their methods over generations, and built things that lasted. In 2023, MIT researchers finally decoded the mechanism. The self-healing lime clasts, the crystal growth that makes the concrete stronger over time. And the beautiful irony is that the modern descendant of that same chemistry is available to you right now for $16 at any hardware store in the country. The real lesson here is not about cement. It is about the gap between what is available to us and what we actually know how to use. Most homeowners panic when they see a crack in their foundation because they lack two things: the ability to diagnose whether it is serious and the knowledge that a cheap, permanent fix exists for the majority of cases. You now have both. So the next time a heavy storm rolls in and you hear water somewhere in the dark below your house, you do not have to stand there in fear, imagining a 5-figure repair bill. You can walk down those stairs with the quiet confidence of someone who understands what is happening, knows exactly what to do about it, and carries the accumulated wisdom of 20 centuries of engineering in a $16 bag. If this knowledge gave you something valuable, hit subscribe. Leave a comment telling us what survival skill or forgotten technology you want us to decode next. Share this video with someone who owns a home. This is the kind of knowledge that should never cost $5,000. Until next time, stay curious, stay capable, and keep building your legacy. This is Historia Prime,